important properties of parallelograms. I'm going to mark them on this picture here. Opposite sides of the parallelogram are going to be parallel. That's where it gets its name. So the way that we mark things parallel is that we put these little arrows on them. So that right there would mark that those two opposite sides are parallel. Also, we'll put like double arrows here to show that these two sides are parallel to each other, but they're not parallel, obviously, to the other two sides. Opposite sides are also congruent, so the length of this side is equal to the length of this side. The length of this side is equal to the length of this side. Opposite angles are going to be congruent. So if I know what this angle right here is, the one in the other corner, the opposite angle right there is equal to it. And that would also be true over here. So if I know what this angle right here is, then I know this angle. These last two I'm not going to mark over here. Consecutive angles are supplementary. That means that angles that are next to each other, such as this one and this one, add up to 180. We're going to see that again later, so I'm not going to spend major time on that. And diagonals bisect each other. The diagonals are going to cut each other in half. Okay? And we'll look at each property in a little more detail. So, a few pieces of vocabulary. Parallel means that you got two straight lines that do not intersect. These should all be like review. Congruent means the same length or same measure. Consecutive means next to each other. Supplementary, here's one that students forget pretty often. Supplementary is two angles that add to 180 degrees. Okay, so supplementary angles add up to be 180 degrees. There's also a word called complementary. That's adding up to 90 there, but supplementary is the one we'll need. And to bisect, which we've already talked about, means to cut in half. So, the opposite sides being parallel, here is marked in this picture. Notice we got our little arrows here, and this just tells us that those lines would never touch there. That's all I have to say about that. Opposite sides are congruent. My picture doesn't really match. The picture just shows the parallelness. So the opposite sides being parallel lets us know this is a parallelogram. So for example, if AD, my examples are terrible really here because it doesn't look right. I need to go back and rework these notes. I think I borrowed these from somewhere and didn't change them to my liking. So like if I know AD right here is 7, then I know BC would also have to be 7. I'm not going to mark BA and CD because they don't look like they're 8. But the picture is not drawn to scale there. But they would be the same also. Opposite angles are being congruent. This is also a bad picture because if I mark all 4 of these angles with a single arc, that is supposed to be telling me that all of those angles are equal to each other. Does it look like all of those angles are equal? It does not. B and D are going to be congruent. A and C are going to be congruent to each other. So if I know angle A is like 36 degrees here, then C is also 36 degrees. But again, bad example because then it says B and D are 110, which is incorrect because they have to, the consecutive sides have to add up to 180. These notes are awful. I'm hoping I copied these from somewhere and didn't change them. And not that I came up with these notes. I don't know. All right. Consecutive angles are supplementary. Let's fix our picture over here again because it's a misleading picture that we really need 2 little tick marks there. So, this property means that angles beside each other add up to 180 degrees. So, examples of consecutive angles are ones that are on the same side. So it could be like A and B are consecutive angles. B and C are consecutive angles. C and D are consecutive angles. And A and D are consecutive angles. So these angles here should add up to 180 degrees. So for example, if I know that this angle right here is 40 degrees, so if angle A is 40 degrees, then what does the measure of angle B have to be? What? 140. Because those two have to add up to 180, which makes it very easy to find all of the angles in this parallelogram, because if A is 40, C is also 40. If D is 140, B is also 140. Okay, here. All right, and the last thing is that the diagonals bisect each other. So wherever the diagonals of your parallelogram intersect, it's going to cut that diagonal in half. So like AE here would be congruent to EC. Okay, let's look at some examples. Okay, in general, these are very, very easy to do. These should be much easier than your triangle stuff that you've been looking at. So if I am looking for AD right here, Joey, what would AD be here? Nope, 68 is an angle. AD is a side. Okay, it's just the same as the one across from it. It would be A. Okay. Hector then asked me for DC. That's his bottom side. What's the length of that bottom side going to be? 15. Just the same as the side across from it. Okay. Samara, next I have angle A. So it's looking for this angle right here. Oh, that sound reminds me. That was a can, right? Cans are fine in the recycling. Styrofoam cups, some of which still have liquid in them, do not go in the recycling, because I emptied it out the other day, and there were quite a few of those. So, especially if you have a styrofoam cup, you will pour out anything that's left before you throw it away. That will keep things neater, and put it in the regular trash. I'm pretty sure we can't take. I mean, I know some styrofoam can be recycled, but I don't think our recycling takes styrofoam. I don't think, unless somebody knows better than me. All right, so this is 68, and I want to know what A is. What would I do, Samara? Perfect. 180 minus 68, which is going to give us 112. Yeah. So 112 degrees, because the two angles on that same side have to add up to 180 degrees. That makes the rest of this pretty simple. Caden, what would be the measure of angle B right here? That one's going to be 68, because it's just the same as the angle across from it. And Maze, what do we get for angle C? 112. Okay, everybody okay here? All right. Okay, for example 2, we have our diagonals drawn in. They don't give us any angles on this. Cannon, what would the length of UT be? That one's going to be 27. All right, Hunter, how about ST? That one's going to be 18. Carson, what about VS? Also not drawn to scale. Like, terribly bad not drawn to scale. It's not 15. It's going to be 7. There. Because the diagonal is going to cut they'll cut each other in half. So like this piece of the diagonal has to equal this piece over here. So that'll be 7. Terribly, awfully drawn to scale because RV does not look like it should be 15, right? Like this is a bad picture. And I should go back and redo it. Fernando, what about VT? 15. Very good. And Abby, what about RT? That one's just going to be 30. We'll just add those two together. All right. Okay, most of these are going to be very straightforward. Questions? All right. Now, you ran into some of these on your triangle worksheet as well. We are going to have some where we've got to set up equations and solve. They're throwing a little bit of algebra in here. They're mostly doing this just to keep you doing some algebra. So if I'm supposed to solve for x here, Jamaja, what do you think we should do here? Good. Those sides are equal, so we just set these equal to each other. 9x minus 25 equals 5x plus 7. Jamaja, how do we solve that? Good. Okay, them. Beautiful. So we'll get 4x equals 32, and our last step, divide by 4. So x would equal 8. And this one only asks us for x, so that would be our answer. If we needed the length of the side, we'd have to plug it back in. Is that it? That's it, isn't it? Okay, so, oh, we got through that in 12 minutes. That was super fast. Easier than triangles. You guys are going to be fine on doing the worksheet, or it's going to be a delta math, all right? Okay.